topic of postfix to infix conversion. Let's go to the algorithm of evaluation of postfix expression, or you can say postfix to infix conversion. In this algorithm, while solving the expression, again we have to take help of stack. It is one of the application of stack which converts the postfix expression to infix expression. We have to scan the expression from left to right. So let's go through the steps. In step 1, we have to add the right bracket to the postfix expression at the end of postfix expression. In step 2, we have to scan the every character of the expression, and we have to repeat step number 3 and 4 until that closing bracket is occurred, which we added in the step 1. In step 3, if we found the operand, then we have to push it onto the stack. Operand like A to Z or 0 to 9 is there, then we have to push it onto the stack. If you remember, while performing infix to postfix conversion, we are pushing the operators onto the stack and we are directly transferring operand into the result array. But here we have to push the operand into the stack. After that, if an operator is encountered, then we have to pop the two top elements from the stack. We have to call it as A and B, and then whatever operator is encountered, we have to evaluate it on the B and A in the form of B operator A, where A represents your topmost element and B is the element below A. We have to push the result of that by operation back to the stack. Then we have to set that result at the topmost element of the stack. And we have to perform these steps 3 and 4 until the entire string is scanned. The final result will be the top of the stack. Now let's try to apply this on the below example. This is the example. We have to evaluate it using the stack and the algorithm of postfix expression evaluation. So let's scan the character one by one. First character is 12, which is operand, so we will push it onto the stack. Second operand is a second character is 7, which is an operand, so we will push it onto the stack. Third is character is 3, which is again a operand, so we will push it onto the stack. Now the next is minus is operator, so we have to pop the two operands, that is 7 and 3, where 3 is the topmost element and 7 is next to the top, so 3 will become A and 7 will become B, and we have to apply operation B operator A, so the operation will be 7 minus 3, the result is 4. We have to push the result of this operation back onto the stack, so my stack becomes 12 and 4. Now next is division, which is again an operator, so if operator is occurred, we have to push the two up, we have to pop the two operands from the stack, which are 12 and 4, where 4 is the topmost element and 12 is next to the top, and we have to represent topmost element as A and the next element as B, so we have to apply operation B operator A, so it will be 12 divided by 4, which is equal to 3. Then push the result back to the stack. Now the next is 2, so we have to push it onto the stack. Next is 1, so we have to push it onto the stack. Next is 5, we have to push it onto the stack. Next is plus, as plus is a operator, we have to pop two operand from the stack, and we have to perform BOA, so 5 is the topmost, so it become A, B is 1 as it is next to the top element, so operation will be 1 plus 5 is equal to 6, so 6 will be push onto the stack. Next is multiplication. So pop the next two operands and apply the operation. 2 into 6, which is equal to 12. So push the result 12 onto the stack. Next operator is plus. So pop the two operands, that is 3 and 12, perform the operation, which is obtain the result and push the result back onto the stack. So the final answer is for this postfix expression evaluation is 15. So here it is your final answer, 15. The algorithm is taken from the book Data Structure Using C by Rima Tareja. Thank you all.